Okay, so here we are on what does the clock say? And we're gonna talk about number 4 now. How many minutes will point P reach its lowest height? And how many minutes will it reach its highest height? Well, remember, it's already here, right? So how many more minutes will it be at its minimum? 20 more. So the minimum, remember we said was 73, so I'll just do, I don't know, I'll put 20 here. So here's my minimum. Would everybody agree with that? And then when's it going to reach its maximum? 50. So if I'm sketching, and have something like this, would you agree with that? Sketch, okay, now I am sketching. Scale and label your axes appropriately. So, okay, I've got them in tens. 5, 10, 15. All right, so here we go. Any thought on where we cross the midline here, on that point right there? Any thought on what that might be? Remember, the minimum is at 20 and the maximum's at 50. Where are we going to cross there? 35. At 35. And does that make sense in terms of the problem? Think about, where is that hand after 35 minutes? Is it going to be straight over here? Doesn't that make sense? That's 80? Okay. Where was it on the midline over here? If I continued it this way, where was it on the midline over here? Where would that be? Well, what did you tell me the period was? 60? Won't this be half a period? So I'm going to back up 30, and that's going to be at 5. I'm at 80. Well, let me finish it off. At some point, it's got to come down and hit the midline again. What would that point out there be? 65, 80? So I've got a period of it done. What if I don't really want to go this way because then I'm into negative time, which kind of makes me uncomfortable. So I think I'm just going to leave that. Is that okay with everybody? Yeah, it just says sketch it. Perfect. Okay, next page. What is the height of point P at time 0? Now, this point right here is time 0, right? The beginning of the problem. How high is point P? This is a little bit twisted. We know that this is 72 and this is 8, right? So we know that to here is 80. What I need to figure out is this green line right here. I have to figure out what that is. Because the height of P above the ground when the problem starts is going to be the 80 plus that green. Agreed? Now let's think about this for a minute. In this little triangle, I know the radius is 7. There's a point here that's x comma y, and y is what I'm looking for. Remember that x equals r cosine theta, and y equals r sine theta. That comes directly from y over r equals sine. do I know theta? Because I know R. I know R. Do I know theta? Oh yeah, you do. Think about it. Think about it. You know it. What's this angle right here? What's this whole angle right here? Well, it's pi over 2, 90 degrees. And at, this would be 5 minutes and 10 minutes and 15 minutes. The whole shebang is 90. So what's this little piece of it? 30 or pi over 6. So this angle is pi over 6. So what's this side? Well, it's 7 times the sine of pi over 6. What's the sine of pi over 6? 1/2. So what's the green thing? 7 times a half? 3.5. So how high is it above the ground? 83.5 inches. If you need an x, our cosine will always find it. If you need a y, our sine will always find it. All right, now we're going to write an equation for this. And according to the problem, we're going to write a cosine equation for this. All right, so how much of that can you do already? Do I know my amplitude? Yes, my amplitude is 7. Do I know my period? 60. So 2 pi over b equals 60. So b equals pi over 30. And do I know my vertical shift, my midline? 80. Now, if I drew a sine curve, but if I have to write a cosine curve, then I either have to start here and make it negative, or here and make it positive. Okay, so if we start here, which is the first one, then we have to find that x coordinate. Oh, I already know that one, don't I? Don't I know that's 20? So I would write x minus 20 and put a negative out in front because I'm starting at the minimum. Or I could leave it positive and write x, what was that, 50? X minus 50. And that would be my cosine curve. Oh, then 8 says, what if it's a sine curve? Well, I can't help myself. That's a perfect negative sine curve. So y equals negative 7 sine pi over 30. What's my phase shift if I'm looking at that as a negative sine curve? X minus 5. The phase shift is actually 5, but my c would be negative 5. Plus, if you wanted to, you could start over here, and then it would be a positive 7, and you would have x minus 35. Everybody okay with that? All right, number 9. Let Q be the tip of the hour hand. The function Q can be used to model the height in inches after t minutes, where 0 corresponds to 10/10. Compare and contrast the graphs of P and Q with respect to each other. Would their amplitudes be the same or different? That's what we're doing here. We're talking about would their amplitudes be the same or different? Different. Why? Who said that? They're different lengths. Does that make sense to you? They're going to be different heights because they're different lengths. How about their maximum? Well, yes, because the amplitude's different, so of course anything associated with height's gonna be different, and minimum, same thing. What about midline? That's gonna stay the same, because aren't we, regardless of which hand you're looking at, aren't we the same amount off the ground? From the center of the clock, I mean? And what about period? Oh, no, the period will be vastly different, because, well, not vastly, but it'll be different, because what's the period of a minute hand? 60 minutes? What's the period of the hour hand? 12 hours, which is 720 minutes? Right, okay, perfect. All right, now we got some review. I finished it this morning. I'm ready to run off another review, but let's join up with our teammates and let's see how much of this review you can get done. We'll join back together in about 10 minutes, okay? So take 10 minutes and start working on this little review. And I will turn it to, let's see what kind of answer it is. You think about that. We're in front of it. Now, Oscar, it doesn't say write the equation. It says write an equation. There are millions of equations. You just want to write one that fits that.
Okay, I was like.
We'll say we take a 1 chance instead of round 1.
Oh, yeah, it's weird. Yes, I'm sorry.
All right. Which of the equations in problem A did you say fit that picture?
First, third, last.
The first one, y equals cosine x. No phase shift, period, 2 pi. I think that's right. That is the cosine. Then you said the third one. The third one is a sine curve that's been phase shifted to the left. Yep, pi over 2. Perfect. That's perfect. Okay, and then which one? The last one. So that's a negative sine curve that's been shifted to the right. Yep, I think you're right. I think there's one more. This is for the math champions who pay attention every day and go home and spend hours learning all the crap Mrs. Ford throws at you. Anna, the fourth one, even function. There's your math champion right there. So remember that cosine is even, which means when you input a negative, it does not change anything. Cosine, if you think about this picture, isn't it a reflection across the y-axis? That makes it even. It's an even function. If you took out your calculator and typed in cosine 10 and cosine negative 10, it would give you the same answer. Okay, guys? Okay. All right. This next one, I hope you got it. What did you say? I hope you said negative 4 ninths.
Yeah.
Because what's tangent? Y over x. So if you know y and you know x, you know the tangent. Okay, that's easy. Now, Oscar was fretting a bit, I think because he was making it too specific. Your job is to come up with an equation of something that has a minimum at -1 and a maximum at 7. Okay, that's it, minimum, maximum. Okay, so what did you think of? What was an idea somebody came up with? Y equals 4 sine x plus 3. Does that meet the criteria? It sure does. Could we have made this a cosine? Could we have changed the period? Yep, because that doesn't have anything to do with the range. This is all about getting your amplitude and midline, right? Perfect. All right, did you get to D? Did you get that far? We have an angle in standard position with intersect center towards the radius 1. Where is point A? Now, remember, when we label our angles, talk about standard position, this is 0. And we're working our way around this way. So all the way around is 2 pi, this would be pi, this is half, and this is 1.5. So the question is 4. Well, in that scheme, where's 4? Isn't it down here? Because what's pi? 3.14? And what's 1.5 pies? Well, what would be, I don't know, whatever 1.5 of 3.14 is, right? But it's bigger than 4. So isn't 4 somewhere in quadrant 3? Okay. And then we want to know the coordinates of that point. So think about it. I want to know x and y. My radius is 1, they told me. How do I find x and y? X equals r cosine theta, and y equals r sine theta. Okay, so go ahead and type them in. That's why they want you to round them off, because that's the only way to do it. By the way, calculator's got to be in radian mode. So I'm not sure how it is for you right now, but it has to be in radian mode. So 4 times 4, negative 0.654, sine 4, negative 0.757. Does that look okay to everybody? All right, let's get the next couple done. Portion of the graph is shown on each of the following intervals. Determine if we're increasing or decreasing concave up or concave down. Now, the very first thing your behavioral eyes notices, you got the whole concave up and down, you got that figured out. But they're asking you about huge numbers like 22. What's happening from 22 to 23 and a half? So we gotta remember that this thing's periodic, right? What is its period? 6. So if we are interested in 22 to 23 and a half, we can back this up by multiples of 6. So what if I subtracted 24 from both of these? Then I would be looking at the interval from -2 to -0.5. Is that on my graph? Yep. So look at your picture from -2 to -0.5. We are definitely concave up and increasing. All right, now 13 to 14.5. Well, let's just subtract 12 this time. Remember, we're subtracting or adding, whatever we need to do, multiples of 6. And why did we choose 6? Because that is the period. So now I'm looking from 1 to 2.5. So from 1 to 2.5, we are definitely concave down and decreasing. All right, you do the last one, 38.5 to 40. See if you can figure out what that is. I subtracted 36 and brought it down to 2.5 to 4. You may have picked a different number. And I got concave up and decreasing. Is that what you did? All right, one more, F. Come on, we got time, you can do it. F says we got a circle. It has a radius of 3. It shows me that in the picture. And I've got 2 angles. I've got my 5 pi over 3 and my pi over 3 angle. And I want to know how far apart they are, basically. Right? So what I'm thinking about doing is forget this bottom part. Can I find my x and y? Actually, I only want my y. Can I find my y? 3 sine pi over 3. Won't that be this height right here? What's the sine of pi over 3? Don't you dare go to the calculator. What's the sine of pi over 3? Root 3 over 2. So 3 times root 3 over 2, which is 3 root 3 over 2. That's this height. Now guys, what's this one? That's 5 pi over 3. What's this height going to be? Same thing. So I want the total height. So I'm just going to double that. And the answer is 3 root 3. Perfect timing. We'll pick up here tomorrow, do my review as we prepare for a bigger quiz. How did today's quiz go?